Let's start with the demonstration of 3D concrete printing. So before that, we'll try to do a small model in SolidWorks, then how to generate the G code in slicing software. So this is the 3D concrete printing process. Here in the first we'll do the model, and then this G code will be given to the 3D concrete printer. So in terms of material preparation, the material delivering system, we have a mixer and then pumping system. Then we'll check the dry run whether it is printing correctly or not. Then the final printing will be done. We have a robotic 3D concrete printer. So in the printer subsystem, first we'll have a robotic arm. Here you can see the assembly. Totally 7 axes is there. One is swivel base, then the lower axis, lower arm. You can see that lower arm portion, and then upper arm roll at the top, and wrist bend, and the tool flank. And the second one is material delivery system. In material delivery system, this mixer, pump, and this hopper complete operation will be there. So we can see that it is attached there. And this is the nozzle. We have circular nozzle of a diameter from 20 mm to 50 mm. Then robot transport unit, the entire robot is stand on this track. The track is about 2.9 meter. In the control system, we have the robotic control system. One is that one, and this is the panel to move X, Y, Z axis. So we'll do a simple model. This is the SolidWorks. You can also use AutoCAD and other softwares to do the 3D model. In the sketch, we can select the top plane. Any geometry that are required for your printing. Then take the smart dimension. So whatever the dimension is required, enter the value. Along with that, unit is needed. Wait. So now this is like plate type. Go to features. You can extrude this one. So whatever the height is required, 500 mm. So this geometry is extruded now. So in order to slice this one, we have to save this one in a STL format, that is stereolithography. After this, we have slicing software, Nirman. So launch, then load an object. So here you can load only the STL files. Other type of models we cannot upload here. So this is the palette what we will keep here for the printing purpose. Then we have option to rotate, to move, or to make it center, or to scale it. If the model is, the dimension is very less, you can increase that one to double or as per your requirement. So place the model. to the required position. Then the main slicing settings is here. The width of a model, like the each layer, what required width you want. If you want 25, you can change. And the height is the layer height. If the minimum is 10 mm because the aggregate what we are using today is 6 mm. So we are using 15 mm height. Then printing speed minimum is 30. So you can also optimize the speed from 30 to 50 or 60 based on your requirement and the material type what you are using. And this is the moving speed from the original point to the place where it is going to print. The robot is going to move with the speed what you are going to give here. And this is the Z speed. After completing each layer for printing the next layer, it is going to take a speed in the Z axis. So it is better to use a smaller, lower value of a speed. Then maximum height of that is your requirement, ma'am. All those are 15 mm. So if you are increasing the aggregate size, then you can go for the higher. Then pattern, if you are printing now, if you want only one layer, then perimeter is 1 is enough. If you want, I can show you for perimeter 1. After slicing, this is the width that you have given and the layer height. Only one perimeter is there. So if you change the perimeter to 2, a 2 perimeter. So after that, slicing is done. Then the robot is connected. Try run mode, connect, and here it will estimate for each layer how much material is required and how much time it will take to complete each layer. Then the overall estimate will be given. So prepare to print. So we can start the printing. We'll start the mix now. On start. we have a robot controlling the pendant. So using this, robot movement can be done with the x-axis, then y-axis, then z-axis. Always before printing, it's better to do the dry run, whether it is printing in the required position or not, to check that. So now we are doing the dry run, placing the robot to the required position. Always make sure the layer is maintained. Then we will enable the software mode. Slicing the object, then making a dry run, connecting the robot to the software, then preparing to print. Once the dry run is okay, we can start mixing the material.
What is the shape of the model that you are going to print today?
Today we are printing the hexagons, twisted model. Now we'll start mixing the material.
This is a mixer. There are admixtures. Get the admixtures, VMA and SB.
Okay. Okay. These are some of the prototypes we have printed using the recycled material. And these are robotic controlling units.
The consistency of the mix has to be checked properly so that there will not be any break-in while mixing. Now we are going to take out the mix as it has achieved the required consistency. They are going to feed the mix now into the hopper. You can see the hopper. So during large scale printing, we actually use a pump. Here we can see the mixer. This is the mixer. We'll directly put it into the mixer and we attach the pump. You can see the outlet here. Through this outlet, we are going to using the feeder pump. So they has to be fed into the hopper. So here we are going to connect it to the feeder pump here, and through this channel, the mix will be enter into the hopper. The small scale printing, we generally feed it directly. We need to make sure the continuity of the mix. So trial extrusion has to be done. So you can see now the trial extrusion will be done so that the continuity will be developed inside the hopper, the matrix continuity. So trial extrusion is started. You can see the hopper is started, it's rotating. You can see the extrusion. Okay. So now it has developed the continuous matrix inside the hopper. So we can go for the actual printing. It has to be lowered. So we need to set the starting point where to enter the coordinates in the system and set the palette position. So it has been already done. So during the dry run, and to adjust the height, initial height of the print. To make sure the palette is absolutely horizontal. You can see the sensor here. When we are feeding the mix to the sensor, so the feeding will automatically stop. So once the hopper is full, so that there should not be any overflow. So this hexagon, what you are seeing is the taper twisted hexagon. The mix, whatever is been used in this is completely recycled mix.
Twisted program ಹ್ಯಾಂಗ್ ಮಾಡೋದು. So we can conclude this demonstration. Any participants have doubt? Online participants? Totally 50 layers printed now. So after the printing, you can check the height of printing, whether uh, the modeled height and the printed height is same or not, in order to check the shape retention factor. these are the few we can do after the printing. We can check the width. So what is the modeled width and the printed width, and the modeled height in the printed height. So after that, you can change the mix proportion or the plasticizers dosage in order to achieve the better print quality.
Is the setting time similar to the normal cement concrete?
Uh, no, it is quite, the setting time is 9 to 10 minutes we have achieved for our mix.
So the bottom layer will get subside very much, right?
Sorry.
The bottom layer will be getting subsided to a large extent if
Yes.
the setting time is
The
that
setting
much
time
large.
is very long, then it would be affected.
So the height will be consistent as that of you have given to that model.
Yes, ma'am. After each test, we will check it. So we'll do the shape retention factor both for the width and the height.
So it's approximately 9 inches. You can also check the layer width.
30 mm.
30 mm or model width is 30 mm. You can check we have maintained as 30 mm.
Any other questions from online participants?